Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of InnoEnergy. Remember that this biomass energy course has 9 lessons. Lesson 5 has an introduction and several videos that go deeper in some applications of biomass combustion. Let's continue with the biomass systems for power generation and steam cycle. Burning biomass produces heat. This heat can be used in very different ways. For cooking, for space heating, for producing domestic hot water, or for power generation. Let's analyze the production of electricity, or power generation. The Rankine cycle is a model used to predict the performance of steam turbine systems. The working fluid follows a closed loop and is reused constantly. In the process 1 to 2, the working fluid is pumped from low to high pressure. In the process 2 to 3, the high-pressure liquid enters a boiler, where it is heated at constant pressure by an external heat source to become a dry saturated vapor. In the superheater, saturated vapor is heated to reach point 3 as superheated steam. In the process 3 to 4, the dry superheated vapor expands through a turbine, generating power. In the process 4 to 1, the wet vapor then enters a condenser, where it is condensed at a constant pressure to become a saturated liquid. Rankine cycle with reheat. Steam can be extracted from a high-pressure turbine and reheated. In that case, an additional superheater raises the temperature of steam until point 5, and steam is expanded in a low-pressure turbine. This increases the efficiency of energy conversion. Let's start analyzing how the heat is produced. Biomass combustion chambers for power generation are similar to those used for burning coal or municipal solid waste. There are 2 main types: grades and fluidized beds. A grade can be defined as the metal part of a fireplace where the fire is located. Grade firing is a type of industrial combustion system used for solid fuels. Instead of fixed grates like in a fireplace, industrial processes use mobile grates, also called traveling grates. The mobile grate is the main part of the combustion chamber. Its movement allows the fuel to move and spread homogeneously along the entire surface for optimal combustion. There are different designs or moving grates, which differ in how the solid fuel is transported. For instance, chain grate stokers and step grates. Chain grate stokers, which consist in a wide endless traveling chain that feeds and supports the fuel in a boiler furnace. Step grates are moved by hydraulic cylinders and pumps, which make the fuel roll down from the top. Let's analyze their main characteristics. The fuel consumption ranges from 100 to 200 kilograms per hour and square meter. The power control is done by means of varying the grate velocity. And the excessive air needed is high, ranging from 30 to 100% of the stoichiometric air. Mobile grates have some advantages and drawbacks when compared with other types of furnaces. The thermal efficiency is higher than in other furnaces. Supports all types of solid, almost without pretreatment. The investment is relatively low. However, short retention times may produce unburned carbonaceous materials. And the grates can cause mechanical problems or require frequent maintenance. A fluidized bed is formed when solid particles are placed under appropriate conditions to cause the solid-fluid mixture to behave as a fluid. There are several types of fluidized bed combustion technologies. In bubbling fluidized beds, the bed particles are kept in suspension by the primary air at comparatively lower fluidization velocities, between 1 and 3 meters per second. The combustion of heat is absorbed from the gas by the heat transfer tubes immersed in the bed. and by a conventional water wall surface. The in-bed tubes produce steam or be used as superheaters. In both cases, they to control the bed temperature. Heat transfer in the convection pass is similar to that for a conventional coal-fired steam generator. Flue gases are normally cleaned using a cyclone. Then gases pass through further heat exchangers. Fluidized beds have some advantages and drawbacks when compared with other types of furnaces. They are emerging as the best technology for biomass combustion due to their flexibility and high efficiency. There are no moving parts in the combustion chamber. For a given heat transfer capacity, the size of the unit is lower than in other designs. Requires low temperatures and excess air, minimizing the formation of NOx. Thanks to the thermal inertia of the bed, it supports large fluctuations in fuel flow and composition. However, certain herbaceous biofuels can have agglomeration problems. Requires continuous bed preparation and maintenance. And can have high running costs, especially electricity consumption. Once the heat is generated by the biomass combustion, let's analyze how the steam is produced. In a steam cycle, the working fluid circulates in a closed circuit. Let's start with the water condensed after the steam turbine. The economizer is a heat exchanger that heats the water up to the boiling point before entering in the stream boiler. This preheating improves the energy efficiency of the cycle. The boiler or steam generator is used to create steam by applying heat energy to water. In general, it is formed by a bundle of multiple tubes in the combustion chamber walls. The steam generated in the water tubes is collected in a drum, which is a reservoir of water and steam at the top end of the tubes. The drum acts as a phase separator for the steam-water mixture. In this part, the steam is a saturated vapor. Superheaters are heat exchangers, where the saturated steam is heated using the hot flue gas from the oven. Steam can be extracted from a high-pressure turbine and reheated. Finally, the wet vapor is sent to a condenser, closing the circuit. Let's analyze now what happens with the air and flue gas. For burning biomass, atmospheric air must be used to feed the combustion process. Primary air is the air supplied to the burner with the fuel that controls the rate of combustion as well as the amount of fuel that can be burned. In some cases, a second stream of air is introduced in the combustion chamber. The secondary air controls the combustion efficiency, aiming to reach a complete combustion of the fuel. The air heater is a heat exchanger that cools the flue gas before cleaning it. At the same time, it heats the combustion air before entering the combustion chamber. Hot flue gases pass through preheaters and the economizer. The purpose of a flue gas cleaning system is to reduce atmospheric emissions of substances hazardous to the environment and health. Their design depend on the combustion technology as well as on the characteristics of the fuel. In general, for clean biomass a filter is enough. Wrapping up. Biomass combustion with steam cycle is a mature technology. Combustion chambers are mainly of two types, mobile grates and fluidized bed. Each one with its own advantages and drawbacks. The water circuit follows the Rankine cycle, producing steam that feeds a steam turbine. In this circuit, the economizer and superheaters allow a better energy efficiency and a smooth operation of the steam turbine. The air circuit provides the oxygen needed for the combustion. Hot flue gases are cooled in superheaters, the economizer and the air heater to increase the energy efficiency. Finally, flue gases are cleaned before sending them to the stack.